Good morning. This is Naz from NB Network Lessons. Hello to all of my calculus lovers. Hope everyone is doing okay and enjoying their day. Thank you so much for joining. My today's topic of discussion under Advanced Calculus, lesson number 67 is polar coordinates. Okay, I'm going to try to explain you what polar coordinates are, and also I'm going to try to see if I can show you a difference between Cartesian way and polar way. So let's go ahead and get started. It's a really interesting topic, by the way. And, in real life, if you're planning to become engineer or scientist, you will use polar coordinates. You've learned a lot, integration, partial by fractions, improper fractions, and so forth. You might not use them, but polar coordinates for sure, if you're planning to become engineer or a scientist or a mathematician. Okay, so let's go ahead and get started. Quick revision. What is a Cartesian way to represent coordinates? So you have x-axis and then you have y-axis, okay? From long time ago, okay, you've been asked to find out what are the coordinates at this point, right? So then we say the coordinates are x and y. That's what we have learned, So this right here is the Cartesian way to represent coordinates. Okay. Now, another thing is that this is just a revision, to be honest with you. You guys already know that if you have a function of x, let's say going like, I don't know, like this, something like this. This is basically y is equal to function of x, whatever this function might be. This function might be x squared plus 2 or whatever. So basically this y is dependent on this x. If x changes, y changes. Okay, so I just wanted to give you kind of like a quick recap before we dive into polar coordinates. So let's go ahead and dive into polar coordinates. Now, in polar coordinates, this is the Cartesian way. Let's look at the polar way. So let's say you have x-axis, okay, and then you have y-axis. That is the same reference point in case of Cartesian way and in case of polar way. I'm going to write this down right here, polar way. Okay, so now in polar way, what you do is that, let's say you have a point right here. Same as this Cartesian way. The way you look at is different. How do you look at it? You look at it from like this. You say from here to here is r, which is the length from this point to this point. Okay? And this right here is theta, angle. Okay? So your angle is positive when you go like this, okay? And your angle is negative when you go like this. So keep that in mind. So then I can write this as polar representation. Representation would be r theta, okay? This is the Cartesian way, this is the polar way. All I'm doing is that I'm representing the same point in two different ways. So this is basically a section in advanced calculus. So let's say now this, for example, let's say this theta is equal to pi over 3. Okay? What is pi over 3? 180 degrees divided by 3 is 60 degrees. So if we have this pi over 3 and let's say R is equal to 1. Okay, so this length from here to here is 1, and this angle right here is pi over 3. So how can I write this in polar way? I can write this as 1 pi over 3. Okay, so this is the polar way of representation. Now let me ask you this. If I'm right here, okay, at 60 degrees, okay, if I go around like this, all right, and then I come back to right here, what is that? What did I just do? I went around from right here, okay, let me draw a dotted line, right here, and then I came back, okay? So that would be 2 pi, okay? So if you recall from, your earlier algebra, calculus, geometry, okay, this right here is 90 degrees, okay? And then this right here up to here is 180 degrees, and 180 degrees is known as pi. So if I go around complete circle, then that's 2 pi. So let me ask you this. If I go ahead and add 2 pi to this, 1 pi over 3 plus 2 pi, am I changing anything? Am I changing this point? Question. No. All I did was that I basically rotated this and came back to the same position. So that's 2 pi. So if I add these two, let's say we do this, 1 pi over 3, okay, I multiply this by 3 and divide this by 3 to simplify that. So then this becomes 6 pi over 3. I did that so that I can have same denominator so I can add them. So then this becomes basically 7 pi over 3. All right. So then I can write this polar representation as 1, and then I can have 7 pi over 3. So this is good. This is good answer. Okay. This right here is good answer. Now I can go back and go one more time. So I can even do this. 7 pi over 3 plus 2 pi. Okay, if I add that up, I'll get 1 and then 13 pi over 3. It's the same thing. This right here represents this point. This right here represents this point. This right here represents this point. So that's my friends' introduction to polar coordination. In my next lecture, I'm going to come back and show you how can we do conversion between Cartesian and polar way and vice versa. It's just like converting miles into kilometers, feet into centimeters, and so forth. I'll see you next time. You take care of yourself and, just keep on loving calculus. Bye-bye.